Welcome back, mathematicians. Another recap video for lesson 2.3, solving simultaneous linear equations in two variables using the substitution method. Now, in the previous video, when we dealt with the substitution method, we dealt with this exact same system of linear equations. And so let's revisit it. Let's dive a little bit deeper here and repeat the same process, but let's do it for a different set of a different variable. So let's get started. Last time we were together, we selected equation 1. So let's go back there. And last time we isolated y. This time let's isolate x. So we're going to continue to select equation 1. But this time the variable that we will isolate is going to be x. Probably shouldn't have checked that off because we haven't completed that step yet, but you get the idea. So let's just jump in here. Let's get under the hood. Let's get messy. All right. Let's rewrite equation 1. 4 times x plus y equals positive 6. Now let's isolate the term with the x. All right. So to get rid of the other term, positive y, we're going to subtract y from both sides. When we do that, let's see what happens. Check this out. We're left with 4x's equals the expression 6 minus y. Now, we're one step closer to getting x isolated, but we're not there just yet. Currently, we don't have 1x, we have 4 of them, and we want to just get 1. So how would we do this? Under any other circumstances, when you were isolating x, you would divide by the coefficient. So let's go ahead and put a fraction bar underneath 4x and put 4 as the denominator because we want to divide by the coefficient. If we want to keep this balance, we're going to need to apply the same thinking to the other side of the equal sign. Let's see what takes place here. X is now going to be equal to 6 minus y divided by 4. Now, when you see that expression initially, if you have any kind of reservation about fractions, this seems a little scary. But let's celebrate because what did we do? We were successfully able to isolate our variable. And now we have this neat or not so neat expression on the right hand side. X is equivalent or equal to 6 minus some number divided by 4. Now, that was part of our goal. Even if this seems a little shaky, stay with me. Check this out. This is kind of cool. All right. We're going to use the substitution method to substitute the expression into the non-modified equation. We did not touch equation 2, so over here I'm going to rewrite all of it. 2 times x minus y equals negative 3. In line 2, we're going to take our newly generated expression over here, and we're going to replace that with x. We're going to substitute it in. I'm going to write that in a different equation, color, sorry. 6 times y over 4. And we're going to rewrite the rest of the equation. So, what does line 2 tell us? It tells us that we're going to distribute this 2 to the algebraic fraction in parentheses. We're going to multiply 2 by what's inside here. Well, whenever we multiply a whole number by a fraction, essentially we take the 2 and we multiply it by whatever the numerator is. So let's go ahead and do that. So let's multiply 2 times 6, which gives us 12, and then 2 times negative y, which gives us minus 2y, and all of that is going to be over 4 divided by 4. Now let's rewrite the rest of our equation. So if you're tracking, nothing crazy is taking place here. This just feels a little uncomfortable. What we have now is an algebraic fraction. And you've had some exposure last year to dealing with this types of scenario. We want to get common denominators so that we can eliminate them. Let's get it out of fraction mode. But before we do that, let's find some equivalent fractions that allow us to do this. So we're going to keep this first algebraic fraction the same, and we're going to turn the remaining terms into fractions that have a denominator of 4. So currently, we could treat this as y over 1. And if we made that 4 times larger, we would have a denominator of 4 and a numerator of 4y. If we wanted to make negative 3 into a fraction with a denominator of 4, we would put a denominator of 4, and in the numerator, we would make it 4 times larger. So negative 3 times 4 would give us negative 12. Now, if we were to divide negative 12 by 4, we see that we still have a value of negative 3. We didn't really change anything. We just changed the format that it's in. Now, doing this allows us to have common denominators because we cannot subtract or add fractions unless they have common denominators, and now we have that. So this allows us to do another property in math, which is multiplying by the reciprocal. And that's going to help us eliminate those denominators. So let's show you what's going to happen here. If we were to multiply both sides by the reciprocal of 1/4, that's multiplying both sides by 4. That would effectively eliminate all of these denominators because multiplying anything by its reciprocal leaves us with one whole. Well, what does that do here? It frees up the parentheses, all that goes away, and all we're left with is the numerator. So we can keep our 12 minus 2y minus 4y equals negative 12. And usually once we do that step, students let out a sigh of relief because the scary fractions are gone. All right. So you might recognize this current line of calculation from the last time we did this. Let's combine these like terms. Instead of having 2 piles of socks at random places in the room, let's combine them all. So if we were to do that, if we were to combine the like terms, we would combine a negative 2y with a negative 4y, which would give us minus 6y. And now it should be, I guess, a little clearer to see that we're now just going to isolate y. So let's do all the math needed to do that. So let's get rid of this term that's with the negative 6y, this positive 12, and we will do that by subtracting 12. We put that line to simplify and clean things up. 12 minus 12, it's gone, leaving us with minus 6y. Negative 12 minus 12 gives us negative 24. And now we have a clean, nice, clear expression. Negative 6 times some number is equivalent or equal to negative 24. To figure out what that value of y is, we're going to divide both sides by negative 6. You might have looked at it and like, oh, negative 6 times positive 4 will give us the value that we're looking for. So I'm just going to bring that up. I had it waiting for me in the video, and now let's keep it moving. All right. If we divide negative 6 by 6, it leaves us with just y. Negative 24 divided by negative 6 leaves us with positive 4. Now, the reason we know this works is because we found that solution last time we did this equation, and we see that even if we choose to isolate a different variable, we get the same result. So let's finish it off. Last time we were able to find out the value of x first. This time we're able to find out the value of y first. So what do we do with this value that we found? Well, let's sub it back into our original equation. So I will just kind of make a line up here so I can scroll back up and get the original equation back into view. Let's rewrite it. 4x plus y equals 6. Everywhere we see y, we're going to replace that with 4 and now solve for x. So 4 times x plus, I guess we can put that in parentheses to make that super clear, plus 4 equals 6. If we multiply that by negative 1, we can free it out of parentheses, as your former teacher used to say, break it out of jail. All right. And so now we're just going to solve for x, subtract 4 from both sides. If we do that, we end up with 4x is equal to 2. To solve for x, 4 times some number equals positive 2. Let's divide both sides by +4. And once again, we see something pretty neat, even though we solved it differently or a different variable. X has a value of 2/4, which is equivalent to 1/2. And so what's our conclusion? We now know our X coordinate, we know our Y coordinate. Button up the whole thing. The solution to this system is the ordered pair 1/2, 4. This is the ordered pair. This is the location where those two lines meet. Hope you found that helpful. Rewind the video, go back and play it if it's helpful. Other than that, over and out.